CTC 250. Welcome to this laboratory discussion about sodas. Yeah, you might be a soda drinker now, but wait till the end of this lecture and you might decide to change off to something a little bit healthier, like wine. Well, what we're going to be doing in this laboratory experiment, we're going to be looking at phosphate content, specifically in soda samples. And the question is why? Why do you want us to go through all of this, right? I mean, why waste our time running sodas in a laboratory and looking for something as silly as phosphate? Well, there's many things that we could be looking for in soda. Phosphate is just one of them. But phosphate's going to be the one that we're going to be focused on. And the reason is because phosphate is, guess what? PO4. And this carries a -3 charge. Well, guess what, people? We're talking about a new piece of equipment here, right? And the equipment is the IC system, which of course stands for ion chromatography. Well, if I have ions, I can measure those samples, and it just so happens that phosphate is an ion, so I can run it on this piece of equipment. And that's why we've decided to do this lab experiment for you. All right, so this lab experiment is basically a very simplistic sample prep. It's taking some soda, that's about it, and we are going to be analyzing the soda samples on the IC instrument for phosphate. Phosphate's not the only ion that can be in soda. We can have tons of different ions in soda, but phosphate is going to be the only one that we're going to be focused on. And I'm getting ready to tell you why, okay? So phosphate is a negative charge, and this negative charge basically means that this is an anion. So we need to make sure that our system is set up for the anion analysis. That's very important. So I want to make sure that I have all of the pieces and parts hooked up the proper way on the IC instrument in order to analyze for anions. All right, now let's talk a little bit more about phosphate before we go really deep into the laboratory itself. So a couple of things about phosphate are showing up on the screen right now. Okay, first, you have to have it. All right, this is a mineral. It is a mineral that's typically found in bones, and you have to have it. You have to have this along with calcium. So we're going to put a big old check beside a phosphorus. We do not want to eliminate phosphorus from the diet. We need it. Now, as with anything, we don't need tons of it, but we do need a little bit in order for us to do our job that we need to do throughout the day. A normal, healthy person typically has a phosphorus level of 2.5 to 4.5, and this unit is milligram per deciliter. All right, and keep in mind that deci is tenths. All right, so 10 deciliters will equal 1 liter. That means that if you have a 2-liter bottle, a 2-liter Coke bottle, well, there's 20 deciliters that's in that 2-liter. Divide that 2-liter up into 20 pieces or 20 parts. That will give you the volume that we're basically talking about here. So take 1/20th of a 2-liter bottle, and that 1/20th volume should have about 2.5 to 4.5 milligrams that you will find there. Extra phosphorus, it can be removed from the blood. And your body normally does this. So if you do eat something, if you do drink something, then all of the extra phosphorus that you take in that your body does not need, it normally does not save it up for a rainy day. It really does get rid of it, and you expel it either through feces or through urine. Yum. Next, extra phosphorus will cause your body to change. And it could, for some people, lead to what we call leaching of the calcium. So if your body detects that there's extra phosphorus, it really does like to go through an equilibrium phase. And if there's an extreme amount of phosphorus that you have ingested in some form or fashion, what we have seen is that your body typically goes through a period of ripping calcium out for this phosphorus compound. So, for instance, phosphorus will typically carry a negative charge. Something that can neutralize that negative charge out are things like calcium, right? Calcium is a positive 2 charge. And that positive and that negative can interact with each other, and then this will neutralize or help neutralize all of this extra phosphorus or phosphate that you're giving your body. But in the meantime, what your body's doing is that it's pulling the calcium as that resource. And we start to see a buildup of the calcium in your blood vessels. Now, that's kind of a problem because if it's building up in your blood vessels, it can also build up in your eyes, in your heart, and also in your kidneys. So, calcium leaching is something that we do not want. And some people's bodies will do this more than others. It's just really what kind of genetic code do you have? Okay, that's going to be a part of it. The other part of it is what are you eating and drinking throughout the day? Because no matter if you have genetics or not, what you eat and what you drink can also play a major role in how your body interacts with the calcium and the phosphate that's circulating in your system. Now, there are organic versions of phosphorus or phosphate. And these organic versions are going to be found in very normal, what you would call healthy associated foods. This could be meat, it could be poultry, it could be fish, it could be nuts, it could be beans, and it could be dairy. All of these will typically carry a very good source of phosphorus. And I say good source because, again, your body does need it. But where's the time where it begins to get too much? And then there's additive versions. All right, so this is version number 1. Version number 2 is an additive version. The additive version is basically these food companies that are putting phosphorus inside of your beverages and your food items that you've decided to eat throughout the day. Well, phosphorus is going to be used for a number of different things. I mean, the list just goes on and on and on. Everything from preservatives to flavor enhancements and all, even colorings. These additive versions of phosphorus will come from mainly fast food. If you love that McDonald's Big Mac and French fries, well, you're probably eating some phosphorus because of that. Canned and bottled beverages. Well, what are canned and bottled beverages? This would be something like your sodas, right? Your Cokes, your Pepsis, your Mountain Dews, your Sprites. Does that have phosphorus? It's a canned and bottled beverage. What about beer? Beer's canned and bottled. Does that have phosphorus? Enhanced meats and processed foods. Well, processed foods could be everything processed, including many of the vegetarian food items that you might see in the grocery store or maybe at the drive-thrus now. Okay? I mean, we've all heard of the fake hamburgers that taste like hamburger, but it's not really a hamburger. It's made out of pea protein. Well, those are processed. They're heavily processed. And in that processing, phosphorus and phosphate can be added to those food products. In 1990s, the average consumer basically ate 470 milligrams per day. And now what we're finding is that that has increased and it has more than doubled. So here's the narrative that I'm beginning to create. The narrative is that you expose your body to phosphate and phosphorus. You never really think about this, at least up until now. You just eat it and you just drink it. It's good. So we get more in our mouth and in our belly. But the problem here is that as time goes on, more phosphate is being used in the food products. And if more phosphate is being used, then we are eating more of it. Well, what are these typical phosphate or phosphorus containing compounds? You're seeing them on your screen right now. Just going to go through and kind of rattle them off. The phosphorus sources that are typically found in food items to you as a consumer will include dicalcium phosphate, disodium phosphate, monosodium phosphate, phosphoric acid, sodium hexametaphosphate, trisodium phosphate, sodium tripolyphosphate, and tetrasodium pyrophosphate. Again, most of these are used as preservatives. Most of these are used to, quote, enhance the flavor. And some of them are found in the additives that they put in for colors and everything else known to man. So the next time that you go and open up that Diet Coke bottle, Diet looks like it's good for you, right? It says Diet on the front. And you're swinging it down. It's giving you that carbonation. It's giving you that caffeine. It tastes good. And it's healthy for you, right? It says Diet. Well, the issue here is that it also brings apart phosphates. And many sodas do. And that's really what this lab is going to be focused on. This lab is going to be focused on beverages. And in particular, it's going to be different sodas that we are going to be paying attention to at this point. All right, so we're narrowing down the field. So what will happen in this laboratory experiment is that we will bring in a couple of different ones. We're going to give you a variety of different types of soda. And these sodas, you could have maybe 3 or 4 to test. You are going to probably dilute those down. You can't run those straight right out of the thing, right? So you're going to have to filter them or dilute them down or do something with them. And we're then going to take those and we're going to run them on the IC instrument. And we're going to look for the phosphate piece that shows up on the IC equipment. And we'll compare them. You know, which one of these drinks had more phosphate than the other? And then we'll rank them, and I'll share with you what brands they were after the fact. Now, I'm going to say soda, but I also want you to know that I can bring in a number of different drinks, not just sodas, but a number of different drinks. I mean, these could be flavored waters, it could be sodas, it could be Gatorades, it could be energy drinks. It could be a number of different ones that you might be exposed to. Another thing that people are kind of surprised to learn is that phosphorus is not required to be listed on the nutritional label. Your Food and Drug Administration and your United States Department of Agriculture, which controls many of the food or the food industry, has decided that they do not want phosphorus on the nutrition label. Now, many times they'll put it in the ingredient label, but they will never put phosphorus on the line of the nutritional label. So if you are looking for products that have very low phosphate for a number of different reasons, you will not look at the nutrition label in order to gauge or judge this. You have to look at the ingredient label. And the ingredient label is not going to tell you how much. The ingredient label is just going to tell you if it's there or if it's not. So if it's there and you are worried about your phosphate intake, then chances are you will probably put it down and not purchase it. But if it was on the nutrition label and it gives you the milligrams of phosphate that you might find in this drink, then the story might change and you'll be like, well, that's not too much. I think that I'll purchase it. But as of this date, the FDA and USDA has not required phosphorus to be put onto the label. Now, their argument is, it's going to be too much, right? I mean, where does this stop? If we have to put phosphorus on there, then we're going to have to put everything beknownst to man on that nutritional label, and we just don't want to do it. So we have to put stops to certain things. And they have made the decision not to put this onto the label for you as a consumer. As far as high phosphorus, what are some things to maybe look out for? Well, here are some beverages on the screen. Beer and ale. Yes, sir. Or yes, ma'am. If you're a beer drinker, you're loving the phosphate. Cocoa, dark colas, chocolate drinks. Then they put pepper type of soda. So Dr. Pepper, I guess, and Mr. Pibb are kind of not included into the dark cola category. I think that's kind of weird, but that's how they've kind of explained it here. Drinks made with milk. You mean like chocolate milk? Yes. Canned iced teas. Oh, bye-bye Arizona. Arizona iced tea, you're not going to be drinking that if you're going to look out for your phosphates. Bottled beverages with phosphate additives. You reckon? I would expect that. Dairy products. Also up on the screen, very high phosphate content. Cheeses, custards, milks, creamed soups, yogurts, puddings, ice cream, liquid non-dairy creamers. All of those, extremely high levels of phosphate that can be found in them. Those are all the good things. All the good things are kind of bad for you. That's the fact of life. Something else, proteins. What protein do you need to stay away from? Oysters, no big deal. Those are slimy anyway. Sardines, I'm not even going to come near a sardine can and open it up. Sorry, don't have to worry about that. Chicken liver? Well, I might be from the South, but that's one thing I do not eat are breaded chicken livers. Beef livers, same deal. Fish roe. Keep the fish eggs away from me. I don't want any of those. You might like them, but I don't. And organ meats. I don't think I'll be eating any of those either. Even when I was a meat eater, I never ate any of those, right? Okay, so those are the proteins that have very high levels of phosphate in them. Again, if you're looking for phosphate content, stay away from those. And other foods, chocolate candies, caramels, oat bran muffins. That's kind of weird that they specifically target that. What about blueberries? Most processed or prepared foods, which is really the majority of the grocery store nowadays, pizza, and brewer's yeast. All of those very high levels of phosphate. So you would want to stay away from those if you are looking at your phosphate intake. Again, all the good things are right up on the screen. Well, this lab is not going to be looking at any of these food items, all right, except for one. And that one will be your drinks. We're going to limit this down to what we want you to measure and compare. So we're going to do something very simple. We don't want you to process samples very heavily in the lab. We just want you to get into the lab. We want you to take these soda samples, which are already a liquid, just dilute them down a little bit. It's going to be very quick, painless, it's easy, and then we'll run it on the equipment. Versus something like a solid food product where we would have to go through, chop and dice and homogenize and extract and filter and double filter, all of that, bad news. We don't want to do that. So what you're seeing on the screen are going to be some different brands of drinks that you might become familiar with. And what I want you to focus on is not the calorie column. And I don't want you to focus on the potassium column either. I want you to look at the phosphorus column that's over here on the right-hand side. This is what we're going to be focused on. This is what we're going to be measuring. And right off the bat, you're going to see something very unexpected. Here in the first piece, up at the very top, you're going to see Aquafina. And this is flavored water. And over here, if you look at the phosphorus contents, they're all fairly high. So people will gravitate toward a flavored water, and they think it's water, it's good for you. It's just got a little bit of flavoring in it. Strawberry kiwi, I mean, perfect for summertime, right? Well, not necessarily. If you're looking for phosphorus, this is going to be a product that you would want to stay away from. And it's water. It doesn't really even fit any of those criteria that I showed you in those previous slides. But then you look at root beer. Root beer is a dark beverage, but root beer is kind of weird because even though root beer is dark, look at the phosphorus content. There's hardly anything in it. That goes on down to the cream sodas, not only A&W root beer, but Barq's root beer as well. And then we finally venture down to the ales, the ginger ales. And all of those ginger ales that are flavored, and all of those seltzer waters that are flavored, all of the tonic waters and the soda waters, flavored or non-flavored, most of those will have a very low level of phosphate. So if this is something that you're looking out for, well, those are very good products for you. But the flavored water is not. Drink the root beer, but don't drink the raspberry Aquafina water. Next, what you're seeing now is Coca-Cola up at the top. And if you look at Coke, it does have phosphate in it. This meets the criteria, though, right? It is a carbonated beverage, and this carbonated beverage really does have a higher level of phosphate, and it's dark. The next section are crushes. You know, the Crush brand. These are typically your oranges, your grapes, your cherry flavors. Those are very low. Orange drinks are going to be a little bit better for you than the darker sodas that you will find out there. The Dr. Pepper, expect it. We knew that it would be higher, and sure enough it is. It's about on par as the Coca-Colas, though. Even the Diet Cherry Cokes, the Diet Cokes, these are also carrying with them higher levels of phosphate, so they're not really any better for you, right? It's still a dark soda. You might have less sugar, but the phosphate is still there. The next page, Fanta Apple, Fresca, Fanta Grape, all of the Fantas, all of the Frescas, typically very, very low. So again, phosphate intake, Fanta and Fresca are going to be your friends, as well as root beer. The rest of them, though, leave them off so far. Then we get to this brand called Fruitworks. Fruitworks comes in different peachy, fruity flavors, typically higher in sugar, but look at the phosphate content here. We're talking about hundreds. This is double the amount of Coca-Cola. Again, if phosphate intake is what you're worried with, you would rather drink a Coca-Cola than a Fruitworks drink, because if you're drinking Fruitworks, you're getting twice the amount or more of phosphate than with a cola or a Dr. Pepper. This screen up at the very top, there's your biggest culprits right here. Hawaiian Punch. Hawaiian Punch is a disaster, people. You know, I know you might like to mix Hawaiian Punch with other mixers to make it even better, but Hawaiian Punch is going to bring you triple, if not quadruple, the amount of some of your dark soda drinks. Again, stay away from them. Canned iced teas do peg positive, not as high most of the time as a soda drink, though. You look at your Mellow Yellows and your Mountain Dews, most of the time, these are very, very good. Your root beers, again, down here at the very bottom, those are also very good as far as phosphate goes. There's one exception, though, and that's the Mountain Dew Code Red. The Mountain Dew Code Red has a higher level than the normal Mountain Dew because this is due to the coloring and the additive that they have added into that formulation. The other Mountain Dews don't really have that, right? I mean, they call it Code Red for a reason, and that's because it's red. There's something different as the additive in the recipe, and it just so happens that that brings with it some phosphate. Next screen, here you're seeing again up at the very top a little bit of the Nest tea. These are fairly low, right? However, if you look at the sweetened or unsweetened normal versions, these are typically carrying with them a little bit more phosphate than their sisters and brothers. Here are your oranges and your Pepsis. Again, all of those are going to peg positive for phosphate. Pepsi really is no better than Coca-Cola. However, if you like the diet versions of Pepsi and the diet versions of Coke, then the diet versions of Pepsi are going to be about triple the amount than the diet versions of Coke. Next screen, this is the last one. Up at the very top, you're seeing Dr. Pepper's counterpart, Mr. Pibb. That's also somewhat higher. Again, though, Pepsi and Coke typically beats it out. You go through a ginger ale, you go through Sierra Mist. All of those are very clean, clear soda drinks. You get down to your Sprites. Those are also, not surprisingly, all less than 1, which is okay. Your Tropicana fruit punches and your Tropicana Twister oranges and everything else that falls in between, those normally do peg a little bit higher, and it's really based on the category that they fall in. So here are the fruit punches, the lemonades, the pink lemonades, the papayas, the strawberry lemons. All of those are worse than a Coca-Cola or a Pepsi. Then down here at the bottom, notice the orange flavors again, the strawberries and the grapes. Those typically carry less than 1. Now, why are we focused so much on phosphate, right? Why did I spend all this time talking about phosphate, talking about what not to do, look at what is in it, make this decision, is it good for you, should you limit it, and so forth? And the reason is because high levels of phosphate really goes back to kidney stones. Now, you're young. Okay, I was there at one point in my time. And you don't really worry about these types of things, right? You eat what you want to eat, you drink what you want to drink, you never gain any weight, you're full of energy, whatever. Go through McDonald's French fries, and then 30 minutes later, go through Chick-fil-A and get you a huge chicken sandwich, and then 30 minutes later, go through Taco Bell and get you a 12-pack. I mean, these are the types of things that you probably have done or are doing right now. The issue, though, is that at a certain point in time, your body begins to change. I call it 30. Once you get over the 30 mark, your body typically decides to start changing. And as you get older, your body will change even more. The issue here is that phosphate intake begins to affect people our late 20s, early 30s. And it's not necessarily genetic, which basically means that one day you can eat all of the phosphate that you want and be perfectly okay. And then the next day, your body decides, I don't want the phosphate anymore. And you begin to have complications. What are those complications? Well, remember, phosphate loves to pull out calcium. And extra calcium is going to circulate through your body, and your body will have a harder time removing that extra calcium that's beginning to get built up in your system. And if you look at kidney stones and the makeup of kidney stones, what you will find out is that 80% of kidney stones are calcium-based. If you have never had a kidney stone, ever had a kidney stone, you don't know what you're missing. You'll be up one day. It'll feel like a brand new day. Maybe leading up to that, you'll feel a little fatigue, a little tired. Your back might hurt a little bit, but it's probably due to what you think is just soreness. And then you'll wake up the next day and you'll have to use the bathroom. And then an hour or two later, you'll have to use the bathroom again. And then again, and then again, and then again. And then you'll get to a point where when you do use the bathroom, not a lot of volume will come out, but it will feel like you're getting ready to explode on yourself. And then the pain hits. And the pain is due to a kidney stone. 80% of kidney stones are calcium-based, which means that your body has used extra calcium to make the stone with. And this could have been prevented if you limited your food and your beverage intake of the calcium or the phosphates, because they're related to it as well. The other kidney stones are also showing up on the screen. 12% struvite, Struvite is just basically a magnesium-based kidney stone. 7% is your uric acid. 1% is cysteine-based, which is a protein-based kidney stone. These are very rare. Not a lot of people get these. If you have kidney stones, 8 out of 10 times, you're going to have a calcium-based kidney stone. Here's a diagram for those of you that never took an anatomy class or a biology class of where your kidneys are located. This is typically associated with a lower back pain. The lower back pain will become uncomfortable. It will kind of hurt. It will bother you a little bit. And it will also be on either the left or the right-hand side. Well, inside of the kidney, you will have these vessels, these openings. And there is a possibility that a stone, extra calcium, will begin to form in your kidney. And they're called the stone because they are very hard and they're rough. They're jagged. And sooner or later, what happens is that this stone dislodges itself. And your kidney will begin to push the kidney stone through your tubing and your channels. For women, it's not that bad. For women, well, you have a wider tunnel for it to come out of. For men, well, this pain is associated to the pain of childbirth. Your tubing is much smaller, and this jagged, large, rough, hard stone is getting ready to be jammed into your very tiny little bitty tubing in order to come out. And you can imagine that all of those jagged little pieces are going to rip, shred, and cause you enormous amount of pain. What they do is that they typically will take you to the hospital, or you will take yourself to the hospital, and they'll give you something to open your tubing up. And for guys, that's typically Flomax. Flomax helps increase the flow of urine, specifically for older men. But it also does a very good job to open it up so these kidney stones can flow through a little bit better. Here's an actual picture of a kidney stone. What you're seeing on the right-hand side of the screen are just different images of the stone, and you can see how jagged and rough that this stone is. So surgically, they can actually go in and remove this stone out of there. Or they have a number of different procedures. They can sonicate them, which basically means use vibrations to break it all up and allow the smaller pieces to flow through, which will give you days of pain, but not as great as one large big lump that decides to come through. And these things are large enough that you can see them in the toilet when they pass. That's right, folks. There they are. Imagine that going through your kidneys. Imagine that going through all of your interior tubing when you decide to pee. That's where the pain comes in, and that's why people look for their phosphate content, because they do not want something that looks like that to come out of them in the very end. Want to know a pretty picture? Here you go. And the bad thing is that these kidney stones can happen at any point in time. Again, you can be in your 20s, never have a problem. You can get in your 30s, and you will have constant kidney stone problems, one after another, after another, after another. And many times it is related to your diet. In some cases, surgery does have to be done. They have to go in, they have to cut you. They have to open you up, and they have to remove these surgically. Maybe, if you're unlucky, a whole kidney. So these things can be prevented. If you, as a consumer, look for your phosphate content food items and stay away from them. Once you get one kidney stone, you do not want another. But once you get one kidney stone, you are prone to have them again and again and again. Now, phosphate's not the only thing that causes kidney stones. I want to make that clear. What you're seeing on the graph right now is this term called glyphosate. Glyphosate is a very common ingredient in what we call Roundup. And what you're seeing is that the blue bar represents the number of hospitalizations due to kidney stones, and the red bar represents the glyphosate types of products that are used on your food items. As you can see, over the years, from 1990 to 2010, the amount of glyphosate went up, 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 which means that Roundup was sprayed on your food items more and more and more and more, which means that they harvested this produce. They harvested all of the corn and soy product in particular with this graph. They processed it. They gave it to you and you ate it. And it just so happens that kidney stone formation also matches this trend pretty well. Now, does this mean that Roundup and other glyphosate compounds are making kidney stones more common? Well, the data looks like it is. But just because one goes up and the other one goes up doesn't mean that they are that related. I know that sounds kind of strange, but they could be. We just need more data to support it. Next are oxalate foods. Oxalate is another ion. We can measure that ion using an IC if that's what we want to do. No big deal. But high oxalate foods will also give rise to kidney stones. And you're seeing all the food items on the screen that are very high in oxalate. Black tea, which includes brewed tea as well as hot and cold. Beans, rhubarb, nuts and seeds, beets, raspberries, dark chocolate, Swiss chard, buckwheat, tofu, spinach, potatoes, yams, wheat bran. Guess what? This is the appetite of a vegetarian. Typically what happens is that vegetarians' bodies will go through changes, and they love to substitute tofu and other soy-related products in exchange for their meat intake. Well, the previous slide already showed you glyphosate administered on corn and soy. That was that graph. And now as a vegetarian, you are probably going to eat more soy-based product. And it just so happens that you will have maybe a higher chance of kidney stones because of that. And that's exactly what happened to me. And I had no clue. I switched to a vegetarian diet. I began to increase my intake of all of the food items that you're seeing here, in particular tofu and soy-based substitutions. It just so happens that soy has a very high exposure to glyphosate, and studies have shown for 10 years now, 20 years maybe, that glyphosate increase also leads to kidney stone increase. But this is just one part of the puzzle, right? Sodas and phosphates can do that as well, but glyphosate is a phosphate-related compound, right? You can kind of see it in the name. So, that's why we're doing the lab. We want to take a few of these beverages that we have brought to you. We will label them. You will not know what they are. We want you to process them. We want you to run them on the IC. And we want you to tell us if, in fact, which one of these, if any, have very high levels of phosphate. Because if they do, this is what could happen if you're not careful. And then we'll release the identities of those drinks after you measure them and after you analyze them. All right? So what you're seeing on the screen is the actual lab document, and I'll let you print this off and read it at your own pace. But what we've done here is that we normally have taken care of the standards for you. A lot of times these standards are already prepared. They're already ran in the machine. It saves you a little bit of time, so that way you're not over there running standards over and over and over and over and over. But you just need to double check with us to make sure this has been done by the time you get there. If not, then here's the recipe to make those standards with. I think that most of you could probably follow this and prepare these standards without a problem, but just in case, there they are, and there's the concentrations in part per million. The sample prep, you're going to take the soda samples and you're going to have to degas them. Now, chances are we will have this already done for you, right? We've bought these drinks a couple of days before. We've pulled them into or poured them into a container. That container is going to make the soda go flat by the time that you get it. And if they're fresh, because you're the first one to do it, just make sure that you put them on a very warm hot plate. Don't boil them. You don't want to boil anything away. But warming them will typically drive off that carbonated gas or that CO2 that you'll find in the product. This has to be done for at least 20 minutes. Again, though, by the time that you get them, they will already be flat, and you might be okay, and you can skip that step. And it says make a 1 to 100 dilution of each sample. All right, so basically a 1 to 100 dilution means just that. You're going to take a volumetric flask, a 100 ml volumetric flask. You're going to put 1 ml of soda into that volumetric flask, and then you add DI up to the line. Make sure that you dilute them very precisely. Make sure that you do it accurately. You don't want to be above the line. You don't want to be below the line. All right? After you do this, you're going to give it a few mixes. Make sure it's all mixed really, really well. And then you're going to filter it using a membrane filter. That's very important because if you don't, it's going to stop up our instrument. And we don't want you to stop up our instrument. Okay? Next is the QC sample. The laboratory will provide you with a QC sample. This is a sample that you will not know what the concentration is. We know what that concentration is, though, and you will process it just like you do with soda. So you'll take the QC, and then you'll dilute it a 1 to 100, and then you'll run that along with your soda samples. And, of course, the instrument that you're going to be using is the Metrome ion chromatography system. It does have an autosampler on it, so you can load everything up on the autosampler tray. You can make your batches, and then you can run your batch and come back on the next day or come back a little bit later to print off your data and begin to analyze it. That's all that there is with the lab. All right, it's as simple as that. So a few soda samples, you're going to dilute them, send them through a membrane filter. If you have been known to not membrane filter these samples the proper way, and your samples get gunked up in the machine, and it makes everyone basically fell down until the machine gets back up, well, we'll give you a 0 for the lab. So we take our membrane filtration very seriously. If you do not filter it the proper way, you will gunk up our instrument. And if you gunk up our instrument, it gunks up everybody else behind you, and no one's data will make any sense. So you will get an automatic 0 for that lab if you are not careful. All right. So the lab document's going to be on Blackboard. You can print that off. The lab worksheet is also going to be up on Blackboard. And this is the worksheet that you've seen really with everything else. As I scroll through, you're seeing very common questions, what type of column, what type of mobile phase. You're going to see areas for you to write in your samples as far as the names and the areas that you're getting from your chromatograms. You'll go through, you'll make your own calibration chart and everything else. So this is what you'll see also within Blackboard. This will be printed out for you, though, so you will not have to worry about this. The only thing that you'll have to do is just pick this up once you get into the lab, as copies will be provided. But you do need to print out the lab directions. That one sheet of paper will not be printed out. So that one you do want to print out, but this worksheet you do not. This is about 5 pages long, and we've made photocopies for everybody. Finally, in this section, you're also going to find a spreadsheet template. And the spreadsheet template is just going to lead you through a way to organize all of the data. So this is pretty simple. There's 4 standards. You just write in your areas of those 4 standards here. You'll use that set of data in order to make a calibration chart that will go over on the right-hand side of the screen. Key in your important pieces of the linear regression line and your correlation coefficient. And then down here at the bottom, you'll have a couple of different samples that you'll analyze. You'll have areas from your chromatogram. You'll solve for parts per million based on your regression line. And then that was diluted. It was a 1 to 100 dilution, right? So you'll have to solve for your undiluted concentration. And then we'll want serving size, right? Serving size we will provide you in the Blackboard page, so that way you'll know what the suggested serving size is. And you'll use your milligram per liter and your serving size to determine how many milligrams were actually involved in that product if you drank the whole thing. Okay. The QC is over here to the right-hand side. The QC sample you'll do something very similar with. Your area, your part per million, then you upscale it because you did a 1 to 100 dilution. What was the actual concentration? We'll tell you that after you print off your data, and then you can calculate a percent error. So how far off was your concentration from the expected concentration? So that template is up. You're more than welcome to use that template or create your own. Most people use it though. Save you some time. Don't be a crazy person. Only thing you got to do is key in your numbers, plot a chart, and then everything there is organized very well. All right? So there is your data and your lab experiment and a little bit of background about the phosphate in cola experiment. So I hope that you took some notes. I hope that you do well in the lab. I think this is fairly simple. A couple of minutes of sample prep and putting your samples in the machine and learning how to use the software, that will probably be the longest, actually, compared to everything else that you'll do in the lab. So good luck. Let us know if you have any questions, and we'll see you in the lab when you get there.